If you're new to FGC, you've likely built a starter robot from GoBILDA's, Studica, Rev Robotics, or AndyMark, and you've probably found you're doing a lot of copying and pasting your code. Today, I'm going to show you a way that you can improve that code really quick, really easily. I highly suggest you because it can make your life so much easier for programming. I'm Coach Pratt, and I've been teaching robotics and design for over a decade, and I've mentored FTC teams to national championship wins. And today, I'm going to show you exactly how you can turn that starter code from GoBILDA into their own separate classes, so you don't have to have one class where all of your objects are created. Now, when you're doing this, it's going to not only make your code more scalable, make it easier to debug, and it's going to make your code a lot simpler to understand. And one thing I do want to make a quick note, this is not a shot at GoBILDA or the other Rev or AndyMark or Studica designers. They are very smart people working in these companies, and they definitely know about object-oriented programming. And I understand why they decided not to show things like this. But this is a really simple way that you can improve their code to be able to make your code a lot more scalable. It uses something called encapsulation. And encapsulation is the idea, if you followed through my program tutorials in the past on learning Java for FTC. If you haven't, you can see those links down below. But it's the idea that you're going to have your mechanism set up in separate classes that your auto and TeleOp could be able to interact with these classes and use them and not having to copy and paste code between classes. I'm sure you've probably found that as you're writing different TeleOp, you're having to copy and paste your arcade drive over, copy and paste your launcher mechanisms over. That's the wrong way of going about programming, and it's just going to end up running into issues where you remember to change a variable on one class, but forget to change it on the other class. So by the end of the day, you should be able to have your code all encapsulated into separate classes so you don't have to run into this problem again. Now, for today's tutorial, I'm going to be using Android Studio, and it's assuming that you just have a setup here. If you don't know how to set up Android Studio, you can take a link in the comments down below. I've got a full tutorial on that. I highly suggest you because it can make your life so much easier for programming. Let's take a look at the GoBILDA starting code here. So we are going to take GoBILDA's starter bot TeleOp, which is available for their Decode season starter bot. And we are going to turn the launcher into its own separate class and arcade drive into its own separate class. So let's get started with doing the arcade drive. So the arcade drive are things like your left drive and your right drive, your left power and your right power, your creating and initializing these inside your init method, as well as your actual arcade drive class and your arcade drive section here. I'm also going to show you a slight improvement so you can make your arcade drive a little less touchy as you're driving around. So the first thing I'm going to do is inside my team code section, I'm going to go ahead and right click I'm going to make a new package. I'm going to call this one my mechanisms package. And inside my mechanisms package, we're going to make a new class. We're going to call this one arcade drive. And inside our arcade drive, we're going to make a private DC motor. And we're going to call this one left drive and right drive. We're also going to make a new variable called a new private double called spin damping. And we're going to set this to 2.0, not 20, 2.0. Now, something I'm sure you've probably noticed is as you're driving around that the left and right joystick is very touchy and you spin really, really fast. So what this is going to do is we can have higher means slower turning and lower means higher and lower means faster turning. Yeah. So this is going to help us make our arcade drive a little bit easier. Now we need some way of being able to create all those motors, and we're going to make an initialization method to be able to do that. So we're going to make a public void called init for short for initialization. And in here, we're going to pass in a hardware map called hardware map. And now we're actually going to create our DC motor objects. So our left drive is going to be equal to a hardware map.get. And this is going to be DC motor.class. And inside the string, you have to put in left drive or whatever it is you wrote for your configuration file on your driver station. I'm going to do the same thing for right drive. It's going to be equal to hardware map.get. And DC motor.class. And again, this one is right _ drive. Now we need to set our run mode for our drivers. Now for my run mode on drives, I prefer to run this using encoders, especially at a start of a tank drive. You don't have to. You can also go ahead and run this without encoder. So I'm going to say that left drive dot set mode is going to be equal to run mode run using encoder. I'm going to do the same thing for right drive.set mode. Is going to be DC motor run using encoder. Again, you're welcome to not include these. If you do include these, you're going to have to plug them in. That's just going to make your driving forward and left a little bit more reliable. Typically on a drivetrain, you have to reverse the left motor. You can either do this by reversing the polarity on the leads when you plug in the motor itself, or you could do it in code. So I'm going to say left drive.set direction, and I'm going to say this is going to be reverse. And this is not DC motor simple, it's just DC motor. So we can go ahead and remove that import statement. And then we also need to set our zero power behavior. On a drivetrain, you typically like to stop them. So I'm going to say left drive.set zero power behavior. In this case, it's going to be brake. And we're going to do the same thing for right drive.set zero power behavior. And again, this is going to be brake. Now at this point, we have fully initialized our drivetrain. Next thing we like to do inside of encapsulation is we like to create getter and setter methods. A getter method allows us to grab a value from our class, and a setter method allows you to set a value in the class. And one of those principal points of an object-oriented encapsulate point is you don't want other objects to be able to, or other classes to be able to have access to the DC motors themselves. You only want them to have access to things that you want them to be able to control. In this case, it's drive. So we're going to make a setter method for the arcade drive. So we're going to take GoBILDA's arcade drive, and we're going to improve this a little bit. So I'm going to make a new public void called drive. It's going to take an argument, which is a double called throttle and a double called spin. GoBILDA calls their spin rotate. I prefer to call it spin. Doesn't really matter. It's more a matter of preference. The first thing we're going to do is we're going to apply damping to that spin, because this is going to make our spin a little bit easier. So I'm going to say that spin is going to be divided by our spin damping method, or our spin damping variable. And again, you can increase this and decrease this up here at the top. Then we're going to actually do our arcade math here. So I'm going to say a double of left power is going to be equal to throttle plus spin, and a double of right power is going to be equal to throttle minus spin. So same logic as before. Next, we're going to clamp and scale our values. So let's say, for example, you take your controller and you push it up to the top right. That's going to send, to the bottom right. That's going to send 1 on the y-axis and 1 on the x-axis, which means you're going to send 2, and that would be 1 to flip around. It's entirely possible that you could send max values, but you actually want to send half a value on another point, and it's not going to scale properly as you expect. So we're going to go ahead and scale these around. So I'm going to make a new double largest, and we're going to say the double largest can be equal to math.max, whatever is the currently largest, to the math.absolute value of throttle and the math.absolute value of spin. So we're going to say whichever one's largest, and then if our largest is greater than 1.0, we're going to clamp everything down. So we're going to say throttle is going to be divided by equal by the largest value. And then same thing with spin is going to be divided by our largest value again. Then we can actually set our motors to our power. So we're going to say left drive dot set power is going to be equal to left power, and our right drive dot set power is going to be equal to our right power. And that's it. That's all we need to be able to actually set up our class. So now let's go ahead and actually put this into our TeleOp. So what we just did is we just took inside of our init statement, we took all of this logic related to those DC motors and we turned it into its own init method. We also took out our arcade drive. We put it into our class itself. So now we can use this arcade drive wherever we actually create our own class. So let's go ahead and let's create a new class for TeleOp. So inside my team code, I'm going to make a new class. I'm going to call this one TeleOp class example. And this is going to extend the op mode class. And above it, we're going to write the @teleop method, or the @teleop signifier. And inside here, we always need two methods. We need a public void initialization statement, and then we need a public void loop statement. And now we're going to make a new instance of that class that we just created. So we're going to say that arcade drive called drive is going to be equal to a new arcade drive object. So now we've pulled this class into our TeleOp example, and we need to initialize or run this init method. So now I'm going to say drive.init, and I'm going to call it with hardware map. Now we can do our arcade drive, which is what we had over here. So inside of our loop, I'm going to say that drive.drive, and we need pull in throttle, which in this case is going to be gamepad1 dot left stick Y, but it's going to be negative left stick Y because it's inverted. And then our spin value is going to be gamepad1 dot left stick X. I prefer to drive with one joystick on the left joystick, just like I would control a car on a video game. If you prefer to keep this on 2 joysticks like I did in the GoBILDA controller, it's up to you, but it's a matter of preference. So we can already see that our code, it's much cleaner on the TeleOp, and it's a lot easier to tell where we're actually initializing our drive and where we're actually calling our arcade drive. Now this one didn't get much simpler, but our code already looks a lot cleaner, and it already feels a little less overwhelming to be able to debug on a competition day. Because if my drive is not working, well, let's check out what might be wrong with the arcade drive class. So now let's go ahead and turn the launcher and GoBILDA's state machine into its own separate class as well. So inside mechanisms, I'm going to create a new Java class called launcher. And we need to create all of our own private variables for all of our motors. So inside the starter TeleOp, we have these initial variables up at the top where we have our feed time in seconds, our stop speed, our full speed, and so on and so forth. So I'm going to go ahead and copy these, and I'm going to paste them into my launcher class. I'm going to go ahead and remove this comment just to make it a little easier. So we have a feed time seconds, stop speed, full speed, launcher target, and launcher min velocity. Now inside these, I'm also going to go ahead and private them so we can't access them from a main class. So I'm going to say private, so we'll just write private in front of all of these. Then we're going to go ahead and make our DC motor. So I'm going to make a new private DC motor X called launcher. And we're going to make a private CR servo. And this one's going to be called left feeder and right feeder. We also need to pull over our feeder timer. So we can go ahead and pull this feeder timer over into our launcher class. And we also need to pull over our enum and our launch state. So I'm going to pull these over into our launcher class. Now I just need to make sure I get rid of the starter.bot to TeleOp. So we have our launch state enum and the actual initialized point here. So with all of our variables set up, we can now go ahead, just like we do in the arcade class, we can do public void init. And we're going to call this one with a hardware map and pass in our hardware map as an argument. So we're going to say that our launcher is equal to our hardware map.get. And this is a DC motor X.class. And in my case, I've called it launcher. Do the same thing with our left feeder is equal to hardware map.get. And this is a CR servo.class. And it is called a left feeder. And somehow I got double parentheses on there. And right feeder is equal to hardware map.get. And again, this is CR servo.class. And it is right underscore feeder. Next, we'll set up for our launcher here. So we're going to say launcher.setMode, and this is going to be a run using encoder mode. We're also going to set its break behavior. So our launcher.setZeroPower behavior, and this is going to be break. Next, we're going to set up our PID coefficients. So we're going to say that our launcher.setPIDF coefficients is going to be run mode, run using encoder, and a new PIDF coefficients. And GoBILDA has set up at 300, 0, 0, and 10, respectively. We'll go ahead and delete those so we can pull it back in. And that's our launcher initialized. Next thing we're going to do is we're going to set up our feeder and reverse that left feeder. So a left feeder dot set direction is going to be CR servo dot direction dot reverse. And this should be CR servo not the simple motor. Also, anytime we initialize our launcher, we want to make sure that our current state is always idle. So when I say launcher state, it is launch state is going to be equal to launch state.idle. So we always start with idle. And then here we're going to say to do, and we're going to stop our feeder motors. So we always make sure our feeder servos start at no power. So they will be holding back those artifacts. So now, just like we did making our getter and setter methods in our arcade drive, we're going to go ahead and make some of these functions. So I'm going to make a new public void stop feeder. And all our stop feeder is going to do is it's simply going to stop our two servo motors. So we can call that anytime we want. So we're going to say that our left feeder dot set power is going to be equal to our stop speed. And our right feeder dot set power is going to be equal to our stop speed. And now when we come back up to our init method, we can simply call our stop feeder. And this will actually stop our motors here. We're also going to have a to-do where we stop our launcher at the beginning, just in case it's not started up. So now we can go ahead and turn our main state machine here into a getter and a setter methods to be able to set that up. I'm going to come into launcher and I make a new public void called update state. We're going to make a switch statement here with our launch state. And our first case is, of course, idle. Inside of our idle, we're actually not going to do anything for our idle case. We're just going to leave it as it is, because we're going to create another method to actually stop our launcher later. So we don't actually want our idle to stop this. And that's a little bit different logic than how GoBILDA has their setup. The outcome's going to be the same, but it makes more sense when we separate into a class here. We're going to make our case called spin up. And here we're going to say our launcher.set velocity, and we're going to set it up to our goal. I think it was, what do we call it? We called it launcher target velocity. And then we're going to say if our launcher.get velocity is greater than or equal to our launcher's min target velocity, we're going to transition states. And here, if our velocity has hit that minimum velocity to be able to launch, we're going to say that our launch state is going to be equal to launch state dot launch. So we can actually send. At the end of this, we'll go ahead and break out of that as well. Now we can make another case for launch state. And inside our launch state, we're going to start both of our feeders up. So we're going to say that our left feeder dot set power to full speed. Same thing with our right feeder dot set power to full speed. We're also going to reset our timer. So our feeder timer dot reset. And then we're going to transition again so that we can check our launching state to count our feeder timer. So we're going to say that our launch state is going to be equal to launch state dot launching, because we're currently in the launching state, and then we'll break out of this. And our last case is going to be our launching case. And inside this, we're simply going to check if our feeder timer dot seconds is greater than our feed time seconds variable. We're going to do another transition event, and we're going to go back into the idle state. So we're going to say launch state is going to be equal to launch state.idle. We're also going to stop our feeder so that our feeder doesn't continuously push our sections through. And then at the end of this case, we're going to go ahead and break out of that. So now we have a method to be able to control our state machine. The last couple of things we need to be able to do is we need a method to start our state machine. We need a method to stop our launcher and stop that move running through. We also need a method to be able to get what our current state is and get our current velocity of that flywheel so that we can have some of that information. So we're going to make a new public void start launcher. And if our launch state is equal to our launch state.idle, so we're currently, idle, not spin up. we're currently in the idle state. We're going to transition states, and we're going to say that our launch state is going to be equal to launch state.spinUp. So now we can call this start launcher to actually run the spin up method of our state machine. We also need some way to stop it. So we're going to make a public void stop launcher. And the same thing, we're simply going to just stop our feeder and stop our launcher. So we're going to call stop feeder. We're going to say our launcher dot set velocity is going to be equal to stop speed. And then we're going to say that our launch state is going to be equal to idle. So it's going to put us back into the idle state. So now we have all of the logic for our state machine set up. We can start the launcher, we can stop the launcher, and we can update our state machine every single loop. Just like we did in GoBILDA code, but now we can do that in our auto method or our auto programs as well. Last two things we need to do is we're going to make a public string. That should be capitalized. Public string called get state. I'm not going to pass any arguments into this, and we're simply going to return our launch state dot to string. We're also going to get our current velocity of our flywheel. So we'll make a public double called get velocity. Not going to pass any arguments into this. And we're simply going to return launcher.getVelocity. So now let's actually use this inside of our main TeleOp class. Just like we did the arcade class, we're going to make a new launcher called launcher. And this is going to be a new launcher. So we made a new instance of our launcher object. And just like we initialized our drive inside of our init statement, we're also going to initialize our launcher. So I'm going to say launcher.init, and we need colon hardware map. And I'm realizing just now that inside launcher, we forgot to, in the init statement, we forgot to actually stop the launcher. So I'm going to go ahead and call stop launcher. So we make sure that we set ourselves back up so our launcher does not start in that position here. So now back in the TeleOp class, we have now initialized both of our objects. One thing we always have to do is at the end of our loop, we have to update our state machine, always. If we are not updating our state machine every single loop, our state is going to get out of point here. So I'm going to say launcher.update state at the end of our loop, and we are done there. So now we can grab, just like GoBILDA did here inside of our main loop, where we use Y to start the launcher and B to stop that launcher. We're going to go ahead and do the same thing here. We're going to say if gamepad1.y, we're going to say launcher.startLauncher, and else if gamepad1.b, we're going to say launcher.stopLauncher. And this is the reason why in our state machine for idle, we did not stop that launcher, because we only want to stop it when we request the stop launcher. It's entirely possible the user presses Y to actually start that launch again. So now we can go ahead and actually print off whatever data we need in the end. So I'm going to say telemetry.addData, and data I'm going to add is state of our launcher, and we're going to say launcher.getState. We're also going to print what our current velocity is. We're going to say telemetry.addData, and this is going to be launcher velocity, and this is going to be launcher.getVelocity. That's it. That's how we can actually turn our code into our state machines into separate classes. And we can see that just how much cleaner this code is to be able to debug. Now, I haven't really added any comments. I need to make sure I go ahead and comment these things through. But a lot of these things are much more self-descriptive, like start launcher and stop launcher are self-descriptive. Same thing with drive.drive. Again, it is self-descriptive. And updating your state is also a little bit self-descriptive. So it's nice to be able to abstract away some of that complexity. If you want some more programming tips or some one-on-one feedback on your project, you can consider joining the community down below. Otherwise, I hope you found this helpful as a way of making your code a little bit more reusable, a little more scalable this season. If something didn't make sense, let me know in the comments down below. Otherwise, best of luck out there this season.